That sound happens 1.7 billion times every single day. In Lagos, in São Paulo, in Tokyo, in New York. Every Pepsi tastes identical. The same citrus-forward sweetness, the same crisp carbonation, the same finish. No matter where on earth you crack it open. Over 200 countries, one flavor. But here's the thing. No factory anywhere in the world knows the complete recipe. The formula is split in half, part A and part B, shipped separately, mixed by machines that don't know what they're combining. And those machines, they're filling 1,200 cans per minute using cold fill technology that locks in 4.0 volumes of CO2 without losing a single bubble. This isn't just a soda, it's a global system engineered for speed and secrecy. Today, we're going inside the machinery that turned a small-town pharmacy tonic into a fizzy empire worth $86 billion. In 1893, a pharmacist named Caleb Bradham was mixing up remedies in his drugstore in New Bern, North Carolina. He created a fountain drink he called Brad's Drink, a blend of sugar, water, caramel, lemon oil, nutmeg, and pepsin, a digestive enzyme. Bradham marketed it as a health tonic for indigestion and dyspepsia. Customers loved it. 5 years later, in 1898, he renamed it Pepsi Cola and started bottling it for wider distribution. But early bottling was a nightmare. Glass bottles were expensive, carbonation was inconsistent, and distribution networks barely existed. Pepsi struggled to compete with Coca-Cola, which had already established a national presence. Bradham's company went bankrupt in 1923 during the sugar rationing crisis after World War I. It went bankrupt again in 1931 during the Great Depression. Then came the breakthrough. In 1934, Pepsi started selling 12-ounce bottles for the same price Coca-Cola charged for 6 ounces. The jingle, "Twice as much for a nickel," became a cultural phenomenon. Pepsi wasn't just a drink anymore, it was a value proposition. Sales exploded. By the 1950s, Pepsi had clawed its way into serious competition with Coke. But the real transformation came in the 1970s with the Pepsi Challenge. Blind taste tests in shopping malls across America showed people preferred Pepsi's sweeter profile over Coke. The campaign was devastatingly effective. Coca-Cola panicked and reformulated their product in 1985, a disaster known as New Coke. Pepsi had won the battle, but the war was just beginning. The Cola Wars forced both companies to completely overhaul their manufacturing. Demand was exploding globally. Pepsi needed to produce millions of bottles and cans daily while maintaining absolute consistency. That meant automating everything, perfecting the concentrate system, and building bottling plants on every continent. The scrappy underdog from North Carolina had become an industrial giant. But scaling up that fast created a new problem. How do you keep the recipe secret when you're shipping ingredients to hundreds of factories worldwide? Here's how Pepsi solved it. The complete formula never exists in one place. Instead, the recipe is split into two parts, Part A and Part B, and they're manufactured separately, shipped separately, and only combined at the bottling plant by machines that don't know what they're mixing. Part A contains the flavor oils, acids, and proprietary compounds that give Pepsi its signature taste. It's produced at a handful of secure facilities, then shipped in sealed tankers to bottling plants around the world. Part B holds the sweeteners, high fructose corn syrup in the US, cane sugar in Mexico and other countries, and secondary flavor components. Different supplier, different route, different security protocol. When both parts arrive at a bottling plant, they're stored in separate tanks. No human ever sees them mixed by hand. Instead, computerized dosing systems inject precise ratios of Part A and Part B into purified water. The machines are programmed with flow rates and volumes, but the operators don't know what's in the concentrates. They just know the system works. This setup means Pepsi can operate hundreds of bottling plants globally without ever revealing the full formula. A factory worker in Manila has no more insight into the recipe than someone buying a can at a convenience store. The only people who know the complete formula are a small group of master blenders at PepsiCo headquarters. Even if a competitor got their hands on Part A or Part B, it would be useless without the other half and the exact mixing ratios. But there's another critical piece of the system: water. Pepsi doesn't just use tap water. Every bottling plant has a multi-stage purification system that strips out minerals, chlorine, and organic compounds. The process starts with reverse osmosis, forcing water through membranes so fine they remove dissolved salts and metals. Then it's passed through activated carbon filters to eliminate chlorine and organic molecules that could create off flavors. Finally, UV sterilization kills any remaining bacteria. Why does this matter? Because water chemistry varies wildly by region. New York City's water is soft and slightly alkaline. Phoenix's water is hard and mineral-heavy. If Pepsi used local water straight from the tap, the drink would taste different in every city. The citrus oils in Part A are especially sensitive. They can clash with calcium and magnesium, creating a bitter aftertaste. By creating a neutral water base, Pepsi ensures the concentrate behaves the same way everywhere. Quality control labs at each plant test every batch. They measure pH, sugar content, and carbonation levels using automated sensors. But here's the thing, they don't test the concentrate itself, they test the final product. If a batch is off, the system flags it, but the lab techs still don't know which ingredient caused the problem. They just know to reject the batch and adjust the dosing ratios. This is how Pepsi tastes identical in Tokyo, Lagos, and São Paulo, despite completely different water sources and local regulations. The Part A and Part B system isn't just about protecting the recipe. It's about guaranteeing consistency at a scale that would be impossible any other way. Once the concentrate is ready, the machinery takes over. And this is where Pepsi's engineering gets impressive. Traditional soda bottling used hot fill technology, heat the liquid to kill bacteria, then fill the containers while it's still warm. The problem? Heat destroys carbonation. The soda goes flat before it even leaves the factory. Pepsi pioneered cold fill, keeping the syrup-water blend chilled at 35 degrees Fahrenheit throughout the entire process. This preserves carbonation and prevents foaming, which would slow down production and waste product. The filling line starts with rotary fillers, massive circular machines with 72 filling heads, spinning in perfect sync. Each head fills a can in 0.8 seconds. The cans move along a conveyor, locking into position under a filling nozzle. The nozzle drops into the can and injects liquid from the bottom up. This reduces turbulence. If you filled from the top down, the liquid would splash and create foam, releasing CO2. Bottom-up filling keeps the carbonation locked in. The pressure inside each nozzle is precisely controlled. Too much pressure and the can deforms. Too little and the fill is inconsistent. Sensors monitor every single can, checking fill level in real time. If a can is even a millimeter off, it gets kicked off the line automatically. Once the cans are filled, they move to the seaming machines. These create double seam caps. Two rollers fold the lid onto the can body in 2 stages, creating an airtight seal. This locks in 4 volumes of CO2, the exact carbonation level Pepsi requires. The seal has to be perfect, a single microscopic gap, and the soda goes flat within days. After seaming, every can passes through a laser inspection station. The lasers measure fill level, cap integrity, and carbonation pressure. They also check for dents, scratches, or printing errors. Defective cans are rejected instantly. The defect rate is under 0.01%, less than 1 bad can per 10,000. From there, robotic palletizers take over. These machines stack 2,400 cans per minute onto wooden pallets, arranging them in precise patterns for maximum stability during shipping. The entire line operates with minimal human oversight. Technicians monitor screens, tracking throughput and flagging issues, but the machines do the work. Pepsi has also invested heavily in sustainability. Closed-loop water recycling systems recover 90% of the rinse water used to clean bottles and cans. That water is filtered and reused, cutting down on waste. And the shift to PET bottles, 100% recycled plastic, required new sorting technology to handle contaminated feedstock. Recycled plastic isn't as clean as virgin plastic, so the processing equipment had to be upgraded to remove impurities without degrading the material. From blending room to retail shelf, the system is built for speed and secrecy. The concentrate protects the mystery. The engineering ensures perfection. The concentrate protects the mystery, but the engineering is pure precision. Pepsi's global dominance isn't just about flavor. It's about the machinery, the logistics, and the science that keeps billions of cans tasting identical. Subscribe to see how other iconic drinks get made at impossible speeds. Drop your favorite Pepsi variety in the comments.